Okay, let's start the section. Okay, my name is Sumit Sagar Hota. I am a PMRA PhD Color, IIT Palakkad. Today we will discuss lecture 16 to lecture 20 by Professor Ashok Tej sir, IIT Kanpur, of the subject Introduction to Airbreathing and Propulsion by NPTEL. Okay. Today this is the fourth week of the live discussion section. Okay. First we see some MCQ questions, then we go for some problems. Okay. Okay, which of the following is correct? Okay, this is about the tip velocity. Okay. So this is very simple formula. Any kind of velocity, if it is there, okay, for any kind of jet, okay, the real formula is always, or any kind of tip velocity is especially mentioned, the answer should be pi nd by 60. Okay, this is in terms of feet per second. Okay, so this is what the some basic formula. So answer will be A. N is your RPM, D will be your diameter of propeller. Okay, and this is your static tip speed. Okay, let's go to next question. Helical tip speed is given by what? Okay, so then what is helical tip speed? Okay, answer is A. It's the resultant of the B tip square plus B square. B is your any actual velocity. Okay. Okay. Okay, why helical? Because tip of the propeller is following a helical path through air. Okay, so next question. Propeller has diameter of 25 unit. What will be the static tip speed of the propeller given n equal to 1200 rpm? Okay, this is a kind of problem of the tip speed. Okay, whatever the formula we just already know. Okay, what are the things given? D equal to 25, n is equal to 1200 rpm. Now let's go to solution. B is equal to pi nd by 60 pi into 1200 into 25 divided by 60
Sir, option
is
A.
equal to 1570.8 unit into rpm. Okay, but here in the only unit is written, it's wrong, but if it is option is there, the answer will be obviously A. Okay, now next question. If a propeller is designed to have 200 horsepower, then find the appropriate diameter for the propeller. Consider two blades. Okay, P equal to 200 horsepower, number of blades equal to 2. Okay, let's go to the solution. D of 2 blade is equal to 22 horsepower to the power 0.25. Okay, for 2 blade this is the formula. So equal to 200 to the power 0.25 is equal to, answer will be 82.73 unit. Okay, so answer will be A. Okay, next question. Let's consider we need to design a propeller engine which has 3 blades. What will be the typical value of the propeller diameter? Engine is expected to produce 400 horsepower of power. Okay, okay, what are the things given? P equal to 400 horsepower, number of blades equal to 3. So what is P? Power produced by engine. Okay, so D of 3 D of 3 blades is equal to, the formula is 18 into HP into 0.25 to the power 0.25. So 18, that is your HP, 400 to the power 0.25. By solving you will get 80.5. So answer is A. Okay. Now next question. Which among the following casting process is used in the casting of the piston? Okay. So the most commonly used method for okay, first of all, piston can be manufactured only in two ways. One is casting and one is forging. Okay. So these are the two options, but if you consider the casting, then in the casting process the piston can be manufactured only with the gravity die casting. Okay, this is the most famous process for and most commonly used process for piston manufacturing. Okay. Hey. Okay, so this is what the idea. Next question. Which of the following is the main region for a bond piston? Okay. Okay. Bond can only takes place because of what? Not hot air intake, not leak of coolant. Okay, more clearance. Okay. So obviously, if there is one detonation, okay, then if there is some fire is there, because of that only bond piston will be there. Okay, and it will be happen at the head of the piston or crown of the piston. So the only reason for that is detonation. For example, in the options, detonation is not there. Okay. So if this option is also there, pre-ignition, okay, then this will be your answer. If both are there, then both are the answer. Okay. If both are there and there is only one option correct, okay, then detonation will be the answer. Okay. Okay, what is the thing? So detonation is the point farthest from the spark plug where hot end gas rapidly release their energy. Okay, and it is the main reason for a bond piston. Okay. Now, which material is coated on the piston to increase the service life? Okay, so in to protect anything, any metal, we will just put some coating. Okay, so here and so in the piston, because the piston is a where it's working in a very robust condition, it's working. So for the so to increase its life, service life, so that it will means it's not required to service industry in 1 month or 2 months. Okay, so we just increase the service life to some years, maybe 5 years, 10 years, it can easily go. Okay, so because of that some coating is required. Okay, and because of that when the coating will go, then only this servicing is required for the piston. Okay. Okay, so the coating is of the material tin. coated on the piston to increase the service life. Reduce possibility of scoring. Antioxidant. Antioxidant means it not going to rust. Okay. And tarnish resistance. Similar meaning. Okay. Okay. Piston is a dash part of IC engine. Okay. A very simple question. Piston cannot rotate. Piston cannot revolve. Piston, maybe you may confuse these two options: oscillate and reciprocate. Okay. Okay. Oscillation means if one point is fixed support is there, and if it will having one without friction, or having less friction wire or string. Okay, if one ball is there, a kind of thing. Okay, some dead weight is there. Okay, so whatever the motion it will perform this kind of a oscillation. Okay, but piston having no this fixed support, nothing is there, na. So it is inside one IC engine. Piston only reciprocate. Okay, so this is reciprocate part. Okay, moving forward and backward in a cylindrical container or cylindrical metals or whatever. Okay, this is what piston is doing. Okay, so what exactly it will do? Okay, okay, these are the piston rings. Okay, so what it will do, seals the inside portion of the cylinder from the crankcase. Okay, using the piston ring. Okay, these are the piston ring. Okay, it will seals the inside portion of the cylinder from the crankcase using a piston ring. This is the work of a piston. Okay. Why the length of the piston in the two-stroke engine is more than compared to the four-stroke engine? Okay. Okay. So answer is obviously A. Absence of valve mechanism. Okay. what is the reason behind it? Because of absence of valve mechanism. And okay, so the reason is because of the absence of the valve mechanism, and intake and exhaust of the two-stroke engine have to be controlled by the piston itself. Okay, so in the two-stroke engine, both the intake and the exhaust are controlled by the piston itself. Okay, and absence of the valve mechanism. Okay, so the length of the piston in the two-stroke is somewhat bigger as compared to the length of the piston in the four-stroke engine. Okay, so these are the. What is that convex part on the piston on a two-stroke engine is known as? Okay. The convex part is known as deflector. Okay, what is deflector? Deflector helps in scavenging and diverts. Scavenging means to remove the exhaust gases, and divert the exhaust gas to move towards the exhaust port. Okay. Okay, this is the work of a deflector. Okay, next question. Using which component piston and connecting rod are connected? Okay, using which component the piston and the connecting rod are connected? Okay, it's a very most common name. The name is Gudgeon pin. Okay, the pin you know na. So if there is a pin, that means if there is also pins are there, maybe one question can be asked. Different kinds of name of pins are there, and one of the pin will be this Gudgeon pin. Okay, so this can be also one question. So you remember also name which kind of pin. If you know also pin. Okay. Okay, so next question. Now, which part of the piston experience high thermal stress? Okay, the answer is obviously simple. It is head. Okay, head of the piston. What the other name of the head? It's called piston crown. If it in the option head is not there, then piston crown is the right answer. Okay. When is the choke is used in the engine? Okay. You mostly see in the different kind of scooters, and even also bikes. We are having one choke. We just pull that choke. Okay. If it is the bike or scooter is not starting, then after pulling it will start. Okay, then we again put it down. Okay, then it will start. Okay, so that choke, when these problems are there, you also see that choke is mostly there in the cold weathers, when there is some raining are there. Okay, or some winter seasons. Okay, that time these problems are there. When the temperature is less than maybe 20 25 degree, it will be less. So 20-25 degree temperature, these problems are common. Okay, so those times, so now here you just get to know only one option having cold. Okay, so if you know also when choke are used, your answer is correct. Okay, answer is cold. Okay, okay, so it's the question how they are asking. The choke is used when the engine is what? Okay, so they just try to confuse you. Okay, I told you the weather conditions, they told you the engine condition. If the weather will be cold, obviously the engine will be also cold. If although it's also in your home also. Okay, so they just try to confuse you like this. Okay, yeah, but if you are having some very good what you call room heater kind of thing and all these things, so that you can maintain the temperature, and your bike is also inside, and when you are waking up in the morning and you are again immediately taking out and again start, then obviously this problem is not there. Okay, choke is not required. So it depends on the temperature, ambient temperature. Okay, okay, what is a choke? Choke is a butterfly valve. Located between the entrance to the carburetor and venturi throat. In between the carburetor and the venturi throat, this choke is present. Okay. Next question. What does the venturi in carburetor cause? Okay. Why we need the venturi? Okay. We know carburetor stores the reserve fuel. Okay. But this venturi helps in increasing the what? Velocity. Okay. Velocity means the air velocity. So that more air will come and it will combust very fastly, and our engine will run smoothly. Okay. So this is what the idea of venturi. Venturi in carburetor increase in air velocity. Okay. And what is carburetor? Main function is to keep a reserve of fuel at constant head. Okay. This is the work of the carburetor, and this is the work of the increase the air velocity, the work of venturi. Okay. Now, where is the lean air fuel mixture needed? Okay. In which condition? Okay, we need the lean air fuel mixture. Okay. Starting anyway, we no need starting. We need the rich air fuel mixture, because we also I told you choke is required, all these things. During acceleration also high amount of fuels are there required. Okay. During idling also idling means no fuel is required. Okay. Or in ideal condition it's there. Okay. Or it's nearly only air is enough, I think. Yeah. So idling is not the correct option. Okay, the cruising is the correct option. Okay, where lean air fuel mixture is required. If that is extremely lean return or like that, then it may be idling condition may be in there. Okay. So the idea. So any other answer will be. Answer is D. So why? Because since carburetor provides the engine, because carburetor controls this fuel supply, na? So at the lean condition, the carburetor gives you the best efficiency. Okay, or best fuel economy, whatever you tell. Okay. So in the cruising time, when you are cruising, so there your economy will be good. If you are riding your bike in 40, okay, and you are cruising in a national highway or a kind of thing, okay, so this will be you get a very good economy as compared to your street roads. Okay, so this is what it's showing, and why the reason I show you. Okay, which of the following is the most accurate petrol injection system? Okay, so always remember, when this comes to petrol, okay, petrol only comes through a port. Okay, petrol cannot come through a manifold, cannot be come through a throttle, and cannot be come through a direct. Okay, there is no direct kind of business. Okay, so it's only come through a port. Okay, okay, port injection. Most accurate petrol injection system. Okay, what exactly this port injection is? Okay, so one injector is there. Injector sprays the fuel into each intake port on the manifold side of the inlet valve. Okay, so injector will spray the fuel into the intake pad where it will intake the fuel, where is the inlet, there it will sprays the fuel. Okay, so this is what the work of a port injection. Okay, and which cannot be done by other injection system. Okay, so that's the reason a port injection system is used in the petrol, is a work in the petrol engines. Okay, what is the value of the rate of flow of fuel if the coefficient of discharge of the fuel is 0.75, area of the jet is 0.885 mm square, density of the fuel is 780 kg per meter cube, and pressure differential causing the fuel flow is 15,000 pascal. Okay, so what we need to find, what is the value of the rate of flow of fuel. Okay, so let's see what are the things given. Delta P is equal to 15,000 pascal, CD 0.75, rho F 780 kg per meter cube, area of the jet 0.885 mm square, 0.885 10 to the power minus 6 meter square. So rate of flow of fuel, QF is equal to CD into A into square root of 2 rho F delta P. Okay, this is the formula. Okay, what is CD? 0.75 area, 0.855 10 to the power minus 6 square root of 2 into 780 into 15,000. Okay, so what is the value you will get? 3.101 10 to the power minus 3 kg per second. Kg per second to gram per second, just multiply 1000. Okay, so the answer is 3.1 grams per second, but there is no 3.1, so the nearest answer is 3.21. so that is the answer. Okay, so the answer is A. Okay, the thermal efficiency of petrol and gas engine is about to dash. Okay, so the answer is very simple, it's 30% only. Okay, so what about diesel engine? The diesel engine is more efficient than the petrol engine. So you see in the vehicles, cars, mostly people will prefer diesel cars as compared to the petrol cars. Okay, but diesel cars also having different disadvantages, especially in the cold days. Its auto ignition temperature is very high, so it will, for igniting or making it faster start, it is difficult in the cold weathers. Okay, so these are some problems of diesel engines also. Okay, next question. It is assumed that all the processes of an air standard cycle are what? We heard one term, isentropic. Okay, what does it mean? Reversible adiabatic. Whatever the air standard cycle, auto cycle is a cycle. Okay, there isentropic processes are there. Okay, or dual cycle, whatever cycle you will go. Okay, so everywhere isentropic processes are common. Okay, here it's written assuming the air standard cycle means you have to find the common in the all the standard cycle. In all the standard cycle, what is the common thing? So all the cycle, one the common thing is your isentropic process. Okay, but in the option there is no isentropic is there. Okay, if in the option isentropic is there, so directly you just choose. Okay, but there is no isentropic. Then what does it isentropic means? You have to know. Okay, isentropic means reversible adiabatic. Okay, so now in the options reversible is there, adiabatic is also there. Okay, then you have to again read the question. It is assumed that all the processes of an air standard cycle. Okay, so in the it's asking only the processes. It does not care about whether the system is adiabatic, isothermal, or whatever it's constant volume or constant pressure. It does not care. Okay, it only want to know what is the extra thing in the process, what it have to assume. Okay, in any kind of air standard cycle. Okay, so the answer should be reversible, not the adiabatic. Adiabatic means, if only adiabatic is there, means what? It's maybe reversible, maybe irreversible. Okay, so you cannot choose the option adiabatic. Okay, So that's the reason the answer is A. This is a kind of tricky question. This kind of question you expect in competitive examinations. Okay. The thermal efficiency of a standard Otto cycle for a compression ratio of 5.5 will be what? Okay. That means you have to know the thermal efficiency formula for the Otto cycle. Okay. What is the formula? 1 minus 1 by R to the power gamma minus 1, and the gamma of the air is 1.4. Okay, so air is written, air standard means air is written. If air is also not written, you have to assume it's as air. Okay, because it's the all Otto cycle or in the air conditions, air standard cycles. Okay, and R is equal to 5.5 given, which is the compression ratio. Okay, equal to 1 minus 1 by 5.5 to the power 0.4. Okay. By solving you get 0.4943. That is 49.43%. What is the nearest option? 50%. Answer is B. Okay. The efficiency of the Otto cycle is increased by increasing what? Okay. Now just 1 second before I show you the what is the formula of Otto cycle. Okay, Otto cycle's formula, only one term is there, that is what? Your compression ratio. Okay, whatever there in the option. Okay, Otto cycle is increased by increasing what? Pressure SH does not depend, temperature does not depend, none of them knows there. So compression is the answer. Okay, no need to see also the question what is there. Okay, directly 1 second the answer is. So this simple question can be tricky. How this simple question can be tricky? Okay, now I just tell you the tricky question, how they will ask. The efficiency of the Otto cycle is increased by the compression ratio by dash. Okay, so the efficiency of the Otto cycle is increased by the compression ratio by dash. Option will be increases, decreases, remains same. Okay, this kind of question will be there. Okay, so they will target this increasing. Okay, in the question, tricky question. Okay, so for that how you will solve. Okay, for that you have to write down the formula of the efficiency. 1 minus 1 by gamma to the power R to the power gamma minus 1. Sorry. So okay, now so he's written which one will increase. Okay, if you don't know if anything increase or decrease or what, so let's try with increasing. Okay, then you go for decreasing. Okay, let's increase the R. Okay, So if R will increase, that means this whole quantity what it will do? Okay, this whole quantity will be what? Less than 1, yes or no? Because if the denominator will increase, then this 1 by something in the denominator, if it is increasing, that means this whole quantity, here I just put this green circle. Okay, so that will what? Decrease, and that should be also decrease, otherwise it is also what? Less than 1, yes or no? So now this thing is less than 1, as well as it's decreasing continuously. Okay, so if it is like that, then if something is decreasing, okay, 1 minus something is decreasing every time, then what about this whole value? This whole value obviously what it will go? Okay, it will always increase. Okay, 1 minus something is decreasing, green circle is there, so it is always decreasing. Okay, that means 1 minus something, that means it's always what? Increase. Okay, if this whole quantity will increase, that means which one will increase? The efficiency of the Otto cycle will increase. Okay, so what is the answer? Answer is obviously compression ratio. That means we are increasing the efficiency. Okay, in your increases the compression ratio also, sorry, compression ratio if it increases, and the efficiency also increases. So that's not the idea. Okay, next question. The Otto cycle consists of what? Okay, so first of all, when this kind of questions are there, so what your first task should be draw the cycle. Okay. Drawing the cycle will solve this problem very easily. This is your T, this is your S. This is your Otto cycle. Okay. What is the Otto cycle? What is 3 to 4? Expansion in the turbine. What is 1 to 2? Compressor in the compressor. What is 2 to 3? Heat addition. And what kind of process is this? Constant volume process. 1 to 2, 3 to 4. AC is constant, entropy constant. Isentropic process. Reversibly is the assumption, I already told. This is what? Q out. What is the process? Constant volume. Okay. So now you know everything. Just you have to write down everything. 1 to 2. Isentropic compression. 3 to 4. Isentropic expansion. 2 to 3. Constant volume heat addition. Four to 1. constant volume heat rejection. Okay, so what is the answer? C. Two constant volume process and two constant entropy process. Constant entropy means isentropic. The constant volume cycle is also called what? Okay, now you see in the Otto cycle, two constant volume processes are there and two isentropic processes are there. Okay, that means they will ask you the question. That means all the three options isentropic process must be involved. Okay, so they ask the tricky question, which one is the speciality of the cycle. Okay, so if there is a Brayton cycle, what is the answer? It's the constant pressure process. Okay, so in Otto cycle, diesel cycle, one constant pressure, one constant volume. Okay, so the answer is Otto cycle. Okay, other cycles are not our syllabus. Okay, so this is Otto cycle. Also called constant volume cycle. Okay, why constant volume cycle? Because constant volume heat addition and heat rejection. Okay, so this is what the idea. A diesel engine has compression ratio from what? Okay, some MCQ question. The answer is C. The diesel engine having the compression ratio of 16:20. Okay. In diesel cycle, the heat addition takes place at what? Again, you have to draw the cycle. And this cycle kind of questions, all can be done with one making one cycle. Okay, you have to draw the cycle. Okay, so this is your volume constant, this is your pressure constant. Okay, so this is what the speciality of diesel cycle. Okay, so Q in, Q out. Okay, compression work, turbine work, This is your diesel cycle. Okay, so I just write down everything so that it will be easy. So any kind of question I will ask, this one thing will be enough. Not heat addition, heat rejection, compression, turbine, everything. Whatever the question will be asked, this will be enough. This one draw will be enough. 1 to 2 isentropic compression. Okay, and 3 to 4 also isentropic compression. This is common in the diesel and Otto cycle. Okay, now the change is 2 to 3. Instead of constant volume, it's constant pressure, heat addition, okay, and 4 to 1 will be here, constant pressure, constant volume, heat rejection. Okay, so now next question. What is the combustion in the spark ignition engine? Okay, obviously the answer is A, homogeneous. And compressor ignition engine, heterogeneous. Okay, okay. A 4-cylinder 4-stroke petrol engine has a 10 cm bore, 15 cm stroke, and uses a compression ratio of 6. The engine develops 25 kilowatt indicated power at 2000 rpm. Find the mean indicated pressure and air standard efficiency. Also, calculate the fuel consumption per hour if the indicated thermal efficiency is 30%. Take the calorific value of fuel as 42 megajoule per kg. Okay. Now this is what the question. This kind of questions can very easily asked in your some parts will be asked in your maybe GATE, NET, and IES. Okay, this kind of exam is very easily asked. Okay, maybe civil services. Okay. Given, what are the things given, how you should write down, I will show you like that. You have to write down 4-cylinder 4-stroke petrol engine R6 D 10 centimeter 0.1 meter, L 15 centimeter 0.15 meter, indicated power IP 25 kilowatt, N 2000 rpm, and small n is equal to capital N divided by 2, and NITH is equal to efficiency 0.3 is equal to 2000 rpm already given, divided by 2. Why? 4-stroke, for 4-stroke engine it's always capital M rpm divided by 2. Okay, if there is a 2-stroke it's only N. Okay, 1000 rpm. Okay, so now what are the things we should find? First is standard efficiency, okay. Second, indicated thermal efficiency, okay. Third is the fuel consumption per hour. Okay, what are the assumptions? Petrol engine works on a standard Otto cycle. Because why? Because reversible is there. In actual petrol engine does not work on reversible cycle. It's obviously irreversible. But we are assuming it is as a Otto cycle. That means reversible. It is there. Okay. Petrol engine works on air standard Otto cycle. Okay. Then another assumption, gamma is equal to 1.4. Okay, so now to find gone, assumption gone, let's go to solution. First we'll find out air standard efficiency of Otto cycle. So what is R? Compression ratio 1 minus R by 6 to the power 1.4 minus 1. Okay, it is 0.511, 51.1%. Okay, so second, indicated mean effective pressure. Okay, what is indicated pressure? PMI. Okay, LA you can remember how to remember this formula. You can very simple. You can use it as Planck. Okay, Planck by 60. Okay, like that you can remember, or something P and Lanka, like that something you can remember. Okay, so you have to find a strategy how you should remember. Okay, I remember it by Planck by 60. Okay, so 25 10 to the power 3. Okay, because we are converting in what? It's megajoule, sorry, kilowatt is given na. So 10 to the power 3, that means in watt it's converts. Okay, so PMI we don't know because that is our indicated mean effective pressure. L we know 0.15. Area we can find out by pi by 4 d square, cross sectional area of a cylinder. Okay, and your RPM for 4 stroke 1000 RPM. What is K? K is your 4. How many cylinders? 4 divided by 60. Okay, now by solving all this you get PMI as 318.3 kilopascal. And 1 bar equal to how many kilopascal? 1 bar equal to 100 kilopascal. Okay, that's the reason why we just convert it in terms of bar. Okay, sometimes in the question they ask in terms of bar. Okay, now third bit is our fuel consumption per hour. Okay, NITH is equal to IP by M dot F into CV. Okay, so our fuel consumption per hour is our M dot F. Okay, it's in terms of kg per second, then we convert it in terms of kg per hour. Okay, NIT is your thermal efficiency. Okay, CV calorific value, IP indicated power. Okay, everything given. So only unknown is the M dot F. Okay, substitute the values. 25 kilowatt, 0.3 efficiency. Convert megajoule per kg to kilojoule per kg because power in kilowatt. 42 10 to the power 3 kilojoule per kg. Kilowatt. What is kilowatt? Kilojoule per second. Kilojoule get cancelled. So this kg go to up. Second is already there in denominator. Kg per second is the unit. Okay. So finally your m dot f is equal to 1.984 10 to the power minus 3 kg per second. But what they asked kg per hour. So you know how to do it. 1 second equal to how many hours? Okay, just do it. 1 hour 3600 second. Okay, then 1 second 1 by 3600 hour. That means you have to multiply 3600 in this expression. Okay, because second equal to 1 by hour. Okay, so just we multiply with this expression 3600 and you will get the answer as 7.14 kg per hour. Okay. Okay, let's go to next question. A single cylinder 4-stroke diesel engine works on the following data. Cylinder bore 15 cm, stroke 25 cm, speed 250 rpm, area of the indicator diagram 6 cm square, length of the indicator diagram 9 cm. The spring constant is 7.5 bar per centimeter. Brake specific fuel consumption 0.24 kg per kilowatt hour. CV of the fuel 42,000 kilojoule per kg. Diameter of the brake wheel 70 centimeter. Rope diameter 3.5 centimeter. Brake load 40 kg. And calculate what are the things we need to calculate: brake power, indicated mean effective pressure, indicated power, mechanical efficiency, and indicated thermal efficiency. Okay, these all are itself are the questions. Okay, I just put all in one question and asked you. So but it itself everything can be asked as a one question. Okay. Okay, so when this kind of very big questions are there, okay, so always you should remember, you should follow the procedure. What are the things given, what are the things you need to find out. Okay, if you go in this way na, it's very smooth. Okay, you can very easily find the answers. Okay, in your exam what you do when you have that much practice na, in your mind it is there what are the things given and what are the things are need to find out. Everything is there in your mind. Okay, but initially when you are starting to do all these problems, start writing. Okay, so that in your exam this is as a practice, it saves lots of time in the exam. And if in your exam you are thinking you write down given all these things and then you can solve, then obviously you are having very good time shortage. Okay, but you should practice by writing all these things so that it will be helpful in the exam. So what are the things given? Single cylinder. But yes, if the question, if it is a essay type question, okay, there this will definitely help if you have a good practice of writing. Okay. Single cylinder 4-stroke diesel engine. 4-stroke means N is equal to capital N by 2. What is capital M? 250. On 25 RPM. How many cylinders? 1. K equal to 1. D 15 centimeter. 0.15 meter. W of the brake is how many? What? 40 kg or what? 392.4 Newton. Always take in Newton. L, what is the length? 25 centimeter. 0.25 meter. Okay. And I already solved here. AI 6 cm square. 6 into 10 to the power minus 4 meter square. Small l 9 centimeter. Okay, small l is the length of the indicator diagram. Capital L is the cylinder. Sorry, capital L will be your stroke. Okay. So L is your 9 centimeter. Okay. Then spring constant. Let's denote it as C. Okay. Because already K is gone for your number of cylinders. Okay. So 7.5 bar per centimeter. Brake. Specific fuel consumption 0.24 kg per kilowatt hour. Okay. Some more things are given. CV 42,000 kilojoule per kg. D brake 70 centimeter. D rope 3.5 centimeter. Okay. What are the things you need to find? Brake power, IMEP indicated mean effective pressure, and indicated power, mechanical efficiency, and ITH thermal efficiency. Okay. So let's go to the solution. First, what is effective brake radius? Let it be R brake is equal to D brake plus D rope divided by 2 is equal to 70 plus 3.5 divided by 2. R breakage comes to be 36.75 centimeter, 0.3675 meter. Okay. Okay. So now you have the air brake. Now you can calculate the torque. What is the formula of torque? Torque equal to T is equal to load into effective brake radius. That means W brake into R brake. Okay. 392.4 into 0.3675. Okay. When you solve, you will get as T equal to 144.2 Newton meter. Okay. So first, brake power. Brake power in what? Kilowatt. 2 pi nt. What you do? Just divided by 1000. Initially it is 60. Now it is 60,000. Okay. 2 pi 250 144.2 divided by 60,000. Okay. The brake power is 3.775 kilowatt. Okay. So next is your indicated mean effective pressure. Okay. So PMI is equal to A by L into C. Okay. What is A given? 6. What is small L given? 9. What is C given? 7.5. Okay, what is ALC? Just you see. AY given 6 centimeter square, small L given 9 centimeter, and C given spring constant 7.5 bar per centimeter. Now what is the answer you will get in unit? It's in bar. 5 bar. Bar to kilopascal. How many kilopascal? 500 kilopascal. Okay. So third, indicated power. IP. So indicated power equal to PMI LANK Planck by 60. Okay, 500 0.25 pi by 4 0.15 whole square 250 by 2 into 1 divided by 60. Okay, then what is the answer? Indicated power is equal to 4.6 kilowatt. Okay, next, mechanical efficiency. Mechanical efficiency formula is brake power divided by indicated power. So 3.775 divided by 4.6, 0.82, 82%. Okay, next bit, indicated thermal efficiency. Okay, first, what is brake specific fuel consumption? M dot F by brake power. Okay, all things are given, just substitute 0.25. Okay, M dot F 3.775, M dot F equal to 2.516 10 to the power minus 4 kg per second. M dot F into CV. What is indicated power? 4.6 divided by 2.516 10 to the power minus 4, 42,000. Okay, 0.435, 43.5 percentage. Okay, so one more question I will solve, then we end the section. The stroke and the cylinder diameter of a compression ignition engine are 250 mm and 150 mm respectively. If the clearance volume is 0.0004 meter cube and the fuel injection takes place at constant pressure for 5% of the stroke, determine the efficiency of the engine. Assume the engine working on the diesel cycle. Okay. What are the things given? Cylinder 250 mm. Okay, length of the stroke is L equal to 250 mm, 0.25 meter. Diameter of the cylinder D equal to 150 mm or 0.15 meter. Then clearance volume V2 is equal to 0.0004 meter cube. Swept volume Vs pi by 4 d square L pi by 4 15 square 0.25 0.004418 meter cube. Now what is the total cylinder volume? Swept volume plus clearance volume. Okay, so what is swept volume? We already found 0.4418 plus clearance volume already given 0.0004 0.004818 meter cube. Okay, so next volume at point of cutoff. What does it mean? V3 is equal to V2 plus 5 by 100 into Vs. Okay, that is equal to 0.0004 plus 5 by 100 into 0.004418. Okay. Okay, so now we get the value of what? V3. V3 means V1, V2, V3 all are like your cycle. When you plot the CI engine means what? Diesel cycle. Okay, so accordingly you just plot it. So V3 means that's V3 in the cycle I just shown previously. Okay, so you're thinking where this V2, V3 came, so that's came. Okay. Because it's written in the question, it's a compression ignition engine. Okay, compression ignition means it will follow his cycle, diesel cycle. Okay. Okay, now what is the cutoff ratio? Cutoff ratio rho is equal to V3 by V2, 0.000 621 divided by 0.004, 1.55 compression ratio. R is equal to V1 by V2. What is V1? Vs plus V2 divided by V2. Okay. So 1 plus Vs by V2. Okay. 1 plus, what is Vs? 0.004418 divided by, what is V2? 0.0004. Okay. If you solve it, you get R as 12.04. Okay. So now you have to remember the Otto cycle efficiency, and as I already show you. Okay. And now this is the diesel cycle efficiency. These are the most important things you have to remember. Okay. Especially in these lectures. 1 minus 1 by gamma r to the power gamma minus 1 rho to the power gamma minus 1 divided by rho minus 1. 1 minus 1 by 1.4, 12.04, 1.4 minus 1, rho 1.55, gamma 1.4 minus 1 divided by 1.55 minus 1. Okay, what is the answer? 0.593, 59.3%. Okay, this is the answer. Okay, so actually in the question this is asked determine the efficiency of the engine. Okay, so this because it's a CI engine which works on diesel cycle, so we just found out the diesel cycle efficiency. Okay, so this is the answer. Okay, with that we just end today's section. Okay, if you have any doubts or anything, okay, you can visit my YouTube channel. This is my YouTube channel, Sumit Sagar Hota. Okay, for the recorded lectures. Okay, so if you have any doubts, you can ask in the comment section. Okay, in that video. Okay, in that particular video, and if there is any doubt, you can also ask in the question and answer forum of NPTEL. Okay, so this is where the thing. Okay, this is where the link. Okay,
Thank you, sir.
okay, thank you very much for the section, and good night.